Hello, so today we are going to do this problem, which is part of today's daily challenge, power of 4. So the problem says we get an integer n, and we want to return true if it is a power of 4, and otherwise we want to return false, right? So for example, what power of 4 means that the number is equal to 4 to the power of some value, right? So for example, 16 true, because 4 to the power of 2 is equal to 16. False is 5 is false. For 1, it's true because 4 to the power of 0 is equal to 1. So let's see how we can solve this. So the solution here should be pretty simple, because what we need to do is just divide and keep dividing while basically, what does it mean for n to be equal to 4 to the power of x? So what it means is that, well, we should be able to divide n by 4 x times, and the result would be 1. That's essentially what that means. And so we can just do this division as many times until we have 1, and if we exit and we don't have 1, that means it's not a power of 4 and we can return false. So literally just using the description of the formula, right? And so how do we do that? Well, just to save ourselves from division by 0 issues, we will check if n equal to 0, we can return false. Okay, because we know 0 is not power of 4. And then while we haven't reached 1, right? So while the result is bigger than 1, and what do we want to keep? When do we want to keep doing it? So if we found that n is no longer divisible by 4, so modulo 4 is different than 0, that means it's not a power of 4, right? So either the first time we divided by 4, it's not divisible, so we know we are done, or after we divide by 4 the first time or the second time or the 8th time, we find that it's not divisible by 4, that means we can't, this here is not valid, so we can return false immediately. So we do that, and then what do we want to do? We want to keep dividing by 4, right? Because we want to divide x times. So divide by 4. And then we can return. If at the end we exited and everything was correct, we can return a true. And that's pretty much it. Because if we, at some point that wasn't valid, we would get this. Now, to make this actually match the formula, we should check if n equal to 1. That means we kept dividing until we reached 1. That's exactly what we are doing here. So let's run this. Let's submit. Cool, so that passes test cases. In terms of time complexity, we do, I think this should be like the order of log of n, I think. But one thing we can do here is simplify this formula. So let's actually do it. So what we can do instead of doing this, because we want to exit if n modulo 4 is different than 0. And anyway, the check for equal to 1 would happen anyway here. So we can just keep going until while n is divisible by 4. And so if it's not divisible by 4, we will exit and we'll find that it's not equal to 1 because we weren't able to keep dividing, and then that will be it. And now with this, we don't need this check for n equal to 0, because if it's equal to 0, we will exit this while loop and we will check if it's equal to 1, it would be false, so we'll return false anyway. So we can simplify like this, and we can run this. And submit. Okay, so that passes test cases. Yeah, so that's pretty much it for this problem. Yeah, please like and subscribe, and see you on the next one. Bye.